This video lecture is meant to give you a good start on the post-lab of the Atomic Spectra Lab. You would have spent some time in class recording the data, which would have been you would have used a spectroscope to look at fluorescent light, and you would have looked at an incandescent light, and you would have looked at least hydrogen gas through a spectroscope. All right, and so this is sort of what the data should look like. The fluorescent light, there were some 5 or 6 bands of color. Incandescent was more of a blended rainbow, and the hydrogen gas had about 3 visible lines. There was a purple, there was a teal, and there was a red. Each one of these bands of light represents a wavelength of light, and if you notice here that those wavelengths are in times 10 to the -7 meters. So this right here, whoops, I actually need a pen. Okay, this right here means that this number is 7 times 10 to the -7 meters. So we're going to go ahead and get you started on how to do the post lab for this lab. The first question, and the post lab is really all about just hydrogen. So we're just going to look at the hydrogen data. The first question says to state the colors of the 4 spectral lines. In this case, we're only going to be looking at 3 of the spectral lines because the 4th one's really hard to see. For each one of these colors, record the wavelength values in meters for each to 2 significant figures. So there was a red line, there was a teal, and there was a purple line. Okay, so we're writing those 3 colors, and then we have to record what their wavelengths actually were. Okay, and what we want to do is, if we look at wrong direction, if we look here, we're looking down at the hydrogen right here. We see that the blue line right here is at about 4.123, 4.3 right there. So that's 4.3 times 10 to the -7 meters. The green is about, we're going to call it about 5.0 times 10 to the -7 meters. And this red line is about 6.5 or 6.6 times 10 to the -7 meters. Okay, so 4.3, 5.0, and 6.5. So we had a 4.3 times 10 to the -7 meters. We had a 5.0 times 10 to the -7 meters. And we had a 6 point, oh gosh, I've already forgotten what it was. 6.5. 6.5 times 10 to the -7 meters. Okay, so now what we're going to do, number 2, based on the spectrum observed for hydrogen and the wavelength values we just estimated, rank the colors of hydrogen spectrum from smallest wavelength to the largest wavelength. So the smallest wavelength would be the purple at 4.3. So purple was the smallest, then teal at 5.0, and then red at 6.5. So purple had the smallest or the shortest wavelength, to red having the longest wavelength. All right, now what you're going to do is you are going to take those 3 wavelengths, and we're going to use that energy equation 3 times. We're going to use that energy equation 3 times. We're going to do it once for the purple, where what we're going to do is we're going to substitute the H and the C, so 6.63 times 10 to the -34 joules times seconds. We're going to multiply that by the speed of light at 3.00 times 10 to the 8th meters per second. And we're going to divide that by the wavelength of the purple, which I believe was 4.3 times 10 to the -7 meters. Okay. So 4.3, yes, 4.3. Okay. So what we're going to do is then, let's see, so seconds will cancel, meters will cancel. You'll do the math and you'll figure out whatever the energy for the purple You're then going to do that another time for the teal, and then another time, I don't know where you're going to fit it, maybe down here, another one for the red. Okay, so you'll do that 3 times for question, whatever question number this is. Okay, then what you're going to do on the next page is list each color you observed in the hydrogen spectrum below and write the energy for each color. So for the purple and the teal and the red, whatever number of joules of energy you just calculated, all I'm asking you to do in this question is to just rewrite your answer in joules. Okay, so this question is really just summarizing the answers that you got in question number 3. There's no calculation here. But now you're going to take question number 5 and take those energies that you just summarized in question number 4, and you're going to rank them from low energy to high energy. So low energy to high energy. You're just going to write the names of the colors down here. 1, 2, 3. Then the last question is, how would you then describe the mathematical relationship between the energy of light and the wavelength of that light? Okay. Does the energy increase as the wavelength increases? Or does the energy of light increase as the wavelength decreases? So I want you to tell me that relationship, and then tell me what kind of mathematical relationship is it. Is it a direct relationship or is it an indirect relationship? So if you could write that using complete sentences. Okay, so when you're done with that, go ahead and staple a grade sheet on it and then turn it in for a lab grade. All right, thanks so much, and I'll see you in the classroom.